Please welcome Anita Manwani, President, TiE Silicon Valley, and Satya Nadella, CEO, Microsoft.
Hello, everyone. What's the mood like today? Awesome. We have a fork here, which is not supposed to be here, but I am so delighted, and we are so honored to be bringing the next speaker on the stage, and you all know who he is. He doesn't need an introduction. Satya Nadella, please come and join us.
Thank you so much.
Thank you.
Thank you.
Before you sit down, I want to give you something.
I'm sorry, what is that?
Before you sit down,
Yeah.
we have something for you. So as you all know, Satya has done some amazing stuff. Just 9% increase in stock yesterday. Imagine that in these troubled times. And more than that, ever since 2014 when he took over, transformation after transformation. Not just in introducing new technologies, having new alliances, but the culture has changed from we know it all to we learn it all. And it shows. It shows in cloud's positioning, it shows in AI, and it shows in every product. So Satya, you have been amazing. And on behalf of TiE Silicon Valley and the leadership and the TiE community and friends, I'd like to present you with Lifetime Achievement Award.
Thank you so much. Thank you. Thank you so much.
Thank you.
Appreciate it. Thank you.
And now, I'd like to invite Navin Chaddha. Navin needs no introduction, but he's a dear friend and supporter of TiE and a dear friend of Satya's. So, Navin, over to you. Enjoy.
You want to sit
You
there?
want to
Okay, how's everyone doing? I actually want to see some more energy. So if people could stand up and give a standing ovation to Satya Nadella.
Thank you. Please.
So Satya, let's start on something else besides AI. How's IPL going?
IPL, I didn't see the scores this morning, but man, that 35 ball 100, that was crazy.
Amazing, man.
Crazy. Yeah, I've been thinking about it, right, which is, what is it, 35 ball 100 or 100 centuries? Both are important and in their own time.
And at the age of 14.
Yeah, it's nuts.
I wish you and I were doing it. Our alternative careers, right?
You dream about it.
Absolutely. So, heartiest congratulations to you for getting the Lifetime Achievement Award. But I had the pleasure of working with Satya in the mid-90s. Both of us ran different product groups, so I have seen him grown. And you know I'm one of your biggest fans, and I think besides the Lifetime Achievement Award, what you heard from Anita, I think you're CEO of the decade. And I used to read books of Jack Welch, and now everybody were kind enough to send us signed books. We essentially gave it to all our CEOs and many, many entrepreneurs when you took over. And for those who don't remember, Satya was on the same center stage when he was the president of Azure in 2013.
Yeah, I remember.
2014 as the CEO.
That's right.
So here is to climbing even greater heights
There you go.
after this.
All good things come after this. Yeah.
Absolutely, absolutely.
That's good.
So this conference is about AI. We're just going to get to it. We started with cricket. Let's start with your journey as the CEO first. I actually used your platform, LinkedIn. You know, you were telling me, man, you're very active. I said, I'm just following your footsteps. So I said, like, let's do an audience poll. So actually, the most popular question is, Tell us 3 lessons looking back you would like to share with the audience as one of the greatest CEO of all times. What did you do?
I think when I look back, a framework for, I think, given the number of founders, number of people who are, working in companies, the real question for all of us is, how do you build institutional strength? I'm not saying longevity itself for a business is a goal, but relevance is. I like to sort of remind even us at Microsoft, we've been there for 50 years, it really doesn't matter, is more importantly, are we relevant to the world in our 51st year, right? So if you sort of say that's the framing, then the 3 things, at least for me, is a good framework to think about is you have to keep coming up with new concepts, right? If you're an established company or founding a company, you have to come up with some new idea whose time has come. But in order to build that new concept, you have to have new capability, right? You and I were talking about sort of your new favorite semiconductor thing. It's like, wow, let's go build something new that is needed, that comes because you have capability, that is fundamentally people, who can build that. But then the key question is, in order to build that new capability, long before it's conventional wisdom, you need culture. So to me, I think whether you're a VC, whether you're an entrepreneur founding a company, whether you're an executive or an engineer working in a company, it's the same thing. You kind of really have a cultural sort of posture that allows you to either skill yourself up or get associated with other people with complementary skills that are needed to build something new that is needed in the world. And that framework for me is kind of how I evaluate, quite frankly, even where we are as a company, where do we need to go. And it's a harsh thing because you kind of have to be in this continuous journey of renewal versus any one time.
No, so true. And I think like culture eats strategy for breakfast, lunch, and dinner. But you're also one of the most compassionate person I've met as a leader, as a human being, at a personal level. Talk a little bit about compassion, right? Like, how important is that?
Yeah, the way I have thought about this, the cultural attribute, right? You start by saying, look, we want to be learn-it-alls and not know-it-alls. That means you have to have the ability. That's the foundation of growth mindset. That means you have to have empathy more than anything else to be able to live through, see through other people's eyes. Because one of the soft skills of innovation, right? It's, we think of it as, it's a soft skill for life, but I think of this as a critical soft skill for innovation is, because after all, what is innovation? Meeting unmet, unarticulated needs of customers. How are you ever going to have that deep insight, right? When I sort of look at founders, that's what's unbelievable, right? Which is they foundationally have some deep insight on some unmet, unarticulated need. Because if that was not the case, why found a company?
Absolutely.
And I always am curious as to how did they come to that idea? And it's that I think it is, you can call it design, mindset or what have you, or design thinking. But really, it's empathy. It's empathy, not, you can have empathy, by the way, looking at log files, right? You look at a log file and you say somebody's struggling with something, and I can build a better product for them, right? So to me, I think this is where I think we narrowly define how one has to be able to be having that learning mindset, be curious, learn, but it does ultimately, come down to us having the ability at scale to see through the world through other people's eyes.
Absolutely, right? It's a people-first world, and people build companies. Yeah. So I think coming back to AI verse, that's what it says. So that was the second topic. Like, you're very, very vocal about these things. Both you and I have had the luck of being through many technology revolutions. The PC revolution, then internet, we worked together, then came social, mobile, cloud. What do you think is the scale of this AI revolution compared to any of the waves we have seen in the last 40 years?
Yeah, it's sort of interesting that, right, with even the waves that perhaps you and I have sort of lived through, this one seems like, some of it is compounding effects, quite frankly. It's right, take even something like Moore's Law, right? I mean, even 5 years ago, the talk of the town was, hey, Moore's Law may be dead, where do we go, where are we going to get compute power? I mean, there was a lot of doomsday scenarios that everybody talked about. And here we are. We have like multiple S-curves, right? First of all, Moore's Law itself seems to be working with these AI accelerators and GPUs. I mean, it's kind of a golden age again for systems. It does feel like, I remember coming to the Valley in early 1990, I was working at Sun, and it felt like that was when RISC was being born and what have you, and it felt like a golden age of systems, and we're back at that again. And you sort of add, so system software, right, whether it is what's happening at the ASIC or the chip level to the system level, to the model architectures. Like who would have thought, like 2 years ago we were sit here and it was all about pre-training. Here we are now, it's all about test time compute. The reality, it's both. And they compound with each other. Then the app server, right? When I look at something like what we're doing with Foundry in Azure, it's all about optimizing. Like if I'm building an application with multiple models, there's a lot that needs to be done at the app, just like why we built a web server, or a .NET server, or a Java server. The next thing is you are really going to have these first-class app servers. So I look at that stack, and I say, this is going to basically be bigger because it builds on the rails that already exist. For example, you look underneath even a ChatGPT, you have not only the model, but you use a persistent store, you are using storage and compute, regular storage and compute, to be able to hydrate the data for test time as well as for training. And so I think it's a pretty exciting time to be a builder and scaling with these S-curves, which are multiple of them.
Great, right? And I'm known to say, right, like let's bring Silicon back to Silicon Valley. It's been a software valley, and you're absolutely right. It's the renaissance of hardware and systems, right? And we also have a whole stack thesis. So let's start with the plumbing layers, which Microsoft is one of the leaders in. What do you see as the role of semiconductors, which were seen as like, hey, it's a commodity, software has eaten the world, now combined with models, add system software, and you call it supercomputer in the cloud. So where do you think the innovation is happening? These are hard problems, right?
That's right. And I think the way I always think about these systems problems is, you know, I was talking to Pradeep Sindhu, who, you know, works at Microsoft, was the founder of Juniper, an unbelievable...
Came through our company, Fungible.
That's right. He's an unbelievable guy because he's just such a first principles thinker. And I mean, like I asked him, you know, how did he come up with the core work underneath Juniper? And his thing was, hey, look, you know, in order to make the internet work, right, because at that time the conventional wisdom was, the internet won't work for something like streaming. Right? I mean, it's a great example. But you got to make it work. And so what do? And so you go and say, hey, let me work top down the ASIC and the software that really makes internet routing work. That type of first principles work is what's happening right now. So I feel like take models. If you really want, like, it's interesting. One of the next things could be these, you know, we know they're memory bound. The question is, can we even have compute closer to memory? So I look at that and say, well, there are lots of companies that are already going to look at that, right? So there is nothing that we have today is a given anymore, or rather is going to, the status quo is shaky, because I think you can start optimizing the entire stack for the new workload. There used to be a gentleman called Paul Moritz at Microsoft, who later on became CEO of VMware. He would always say, when you're in the infrastructure business, fall in love with whatever is the next generation workload, and then try to think about the next of scale, and rewire the entire thing. And that's, I think, where we are. And I'm sure you as a VC, we as a hyperscaler are continuously looking at, like, 2 years from now, 4 years from now, what's the scale of compute storage network? And what is needed,
you guys are building
and it's that joint design. Like, that's the thing, you know, which is you got to think about not just an ASIC, but the ASIC, the compute, the network, and all of it in its entirety.
Yeah, I agree, and that's why companies like you are even innovating at the silicon layer. You guys are innovating at the connectivity layer, power, cooling, right? These are really, 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 and for the audience.
Yeah, I mean, cooling is like, who would have thought? Like, I thought I joined a software company, and of course, I look at my CapEx budget and I say, whoa, what happened there? But nevertheless, the cooling in a data center is one of the biggest challenges we're going to have. And the point is, it's differential cooling. There's an AI accelerator rack, and there's the rest. And so you want to be able to manage through software-defined power is where we are now.
Absolutely, and I think for the audience, I would highly recommend, right, to look at these problems. People who worked on deep tech, it's their era. It's the golden era because the system problems are massive. The scale at which Sun Microsystems, like even the mini computers, mainframes did it, this is like 1000x or more of it, right? So coming back to your favorite topic, right, like on models, right, like where do you think you've talked about small language models, domain-specific models, vertical models? There's a lot of people here in the audience, they're thinking, is the game over, or where do you want to give them advice? And you guys are doing a lot of cutting work beyond the transformer models. So where is the opportunity?
Yeah, I mean, I think, first of all, it's great to see even in that layer, you know, obviously OpenAI clearly set the pace by the innovation they were able to do, and we were very obviously thrilled to partner with them and get them to this level of success. But it's also great to see what's happening in open source, what's happening in multiple closed source. Each one is building on the other's ideas even that are coming, right? You know, as soon as some innovation happens in closed source, you see an open source version. Reasoning models which were not there even just a year ago, now they're in all model weight sizes. We launched even yesterday a bunch of new Phi models with reasoning. So the fundamental thing is, I feel we have now, like somebody I saw on LinkedIn, a post someone put, which is we have all the models where we can now stop this second if we wanted to, and for the next 10 years keep building great products. We're obviously not going to stop, but the point is, interestingly enough, as a product builder, you have to be ready for the next sample. That means you have to have the agility to be able to keep riding linearly with model capability improvement. And that, I think, is the frontier for product building. And I feel, and I always say, you know, today this conventional wisdom is more, you know, compute is, or intelligence is log of compute, right? I think that's kind of how Sam describes it, which I obviously buy and ascribe to. But it's sort of, I always say, God, there's one math breakthrough away from somebody coming with some other formula. And say, maybe, you know, that you don't really need to be a log function. And that, you know, in some sense, you know, when people say DeepSeek moment, that was what it was, right? Which is, the reality is O1 already had figured out, I mean, OpenAI had already figured out internally that we can really optimize these models through online RL and COT prompting, and that was really the regime, right? And now it's out there, and so therefore, what's the next thing that will be like that, which says, oh, wow, we can get more efficient or more capable.
Absolutely.
And
right.
I think that that's where, it's also an unbelievable time to be an AI scientist, right? It's all ultimately a math thing. We're all trying to figure out what is this thing that we do in this organic thing that we have, and can we, you know, do things that it does in a power efficient way and build that capability.
No, great, right? And we are seeing models which are built on these transformers. They augment them for domain-specific stuff like healthcare, financial services, security. We even have a chip engineer where you can't just do it on the open models. But I was at Davos with you, right? Like you were talking about even like physical sciences. So what's your view? Because there hasn't been much innovation. So how do we take this and apply it to sciences?
Yeah, no, I think that that's right. I mean, if I think about the three broad domains in which we think about the application of AI, one is, of course, cognitive work and knowledge work. That's bread and butter for us, and it's, I think, where, starting from coding to general knowledge work to business process work is where a lot of, I think, everyday use products today already are mainstream. But the other one is physical. That's all the robotics domain, the autonomous domain, the drones, and what have you. It's real because, after all, with these multimodal models with real-world prompting, essentially, right? I mean, if the world was the prompt, what does a real-world model do? And that, I think, is another area. And the third is science, right? So when I think about science, there's two issues, right? What is the core of science, which is, up to now, the way we have been able to deal with it is by doing simulations, right? We're all, like, HPC as a category was fundamentally born underneath scientific simulation. But it turns out that to simulate nature, right, on a von Neumann architecture, you just have approximations. There's no such thing as a perfect simulation. That's why we are very, very excited about even quantum, because ultimately, the quantum computer is the real breakthrough at utility scale when you really think about simulating nature. But AI is about reducing that search space, right? So you want to discover a new material. AI can help, in fact, speed up the HPC compute by coming up with the candidates much better to simulate. So that is where we're seeing, right? So we have essentially these models that are derivatives of transformers, right? Like MatterGen or what have you, which do have, like, one of the things is you can give it some inductive bias, right? You don't have to start without any knowledge. You can sort of think about these model architectures that do have some inductive bias. So there is a variety of models now that you can sort of get to on Foundry, which are for different domains, biology being the hardest, after all. But I think when it comes to computational chemistry and material science is where I think we'll see rapid progress. And you saw that. We went and produced with the Pacific Northwest National Lab a new material that reduces lithium content in a battery, right, by 70% or what have you. And we went and fabricated it all the way. So that type of stuff, which, by the way, would be great, like in data center, we talked about cooling. You'll see us do some very innovative work in that domain, using these models to discover new materials that then are going in to help us, in fact, with some of the challenges we have around power.
Great. So I think moving up the stack from the plumbing layer, there's a lot of talk about, like, developer tools, vibe coding, developer sphere with all the tools Microsoft and the other startups, unnamed, are creating. That, hey, the number of developers will shrink, builders will shrink. I look at it the other way, with democratization using conversational interfaces, vibe coding. Now 8 billion people, anybody in the audience can be a builder, right? So what are your views, and what are you guys doing for this to be the great equalizer so that billions of people can program, billions of people can become creative? So what are your views on what is this going to do with humanity? Because there's a lot of fear, my job will go away. That is, some job displacement always happens when new technologies come, but in the end, humans win. So what are you seeing in this vibe coding development space?
You framed it the right way, which is, the reality is, you come at it from both sides. You come at it, one of the metaphors I think about is, let's say in the mid-'80s, how did sort of offices operate, right? In the mid-'80s or early '80s, this is pre-PC era. You had, people who, we had a typist pool, right? To type up inter-office memos. We had a slide-making pool, right? People who would do slides. Yep. And then all of us became PowerPoint users and typists, right? Like, who would have thought that there may be 5 billion people in the world, if somebody from Mars came and said, what do humans do? They would think they type.
Especially VCs.
Yeah. Right, so in some sense, we did, through technology, democratize that's why I think sometimes we conflate the knowledge worker with today's knowledge work. I think we as humans have had the capacity to take new tools and reshape the work we do, the work artifact we create, and the workflow with new technologies, right? We are capable of getting to that next point of leverage or abstraction by using new tools. So if you take something like that, even in software development, the reality is, to be a software developer today is fantastic. In fact, my ability to be able to be more productive, stay in the flow. Like one of the things that was the most beautiful thing about the design of GitHub Copilot is it brought intelligence back into the IDE. Right? I'm in the IDE. I really don't want to go to 15,000 different forums, copy paste code. I just want to be in the state of flow. Code completions is one. I want to have a right rail chat. I want to be able to have even agent mode right there that I can give it high-level tasks. And I just can stay with my code base, right? And be thinking about that. And so that's just beautiful, right? So productivity and the state of I'd say just the satisfaction you get after 2 hours of coding is a lot better with all these tools. The quality is also a lot better. It's not about just completely assigning back, right? You may write some code and then you may assign the AI the pull request to do the code review, or the other way around, right? So there's a lot of symbiotic work that's going on. And by the way, I love vibe coding, but let's not sort of overstate it, right? Not everything in life is just green field.
Yep.
Most of our code bases require a lot of work. In fact, I look at the IT backlog, right? Just here's a dream. You go to all the companies in the world, small businesses, large businesses, and just say, I wonder how many engineers are required in order to take all that backlog away. I mean, that'll be, what is it? I mean, it may require all 8 billion of us to be coding.
Absolutely.
So that's another way to frame even the opportunity ahead. And then know that everything, just like, hey, we can all write documents. I think it'll come to a state where we can all write code. But then there are also people who are heads down managing code bases at scale and with leverage, with deep skills, right? If you want to do a kernel optimization for an inference fleet, that skill is still going to be a required skill for many, many years. And by the way, we'll need many more of those people as well. So anyway, so I think that it's a lot more elastic than we give it. Like there's this lump of labor fallacy, I think is what the economists call it. You shouldn't buy that. I think the labor markets are more elastic, but it does require you to reskill. It requires us to not be afraid of the new tool, but use it and then say, how do I get more leverage in my work? That, I think, is what all of us will go through.
Yeah, and I think my feeling is there's no reason to be scared of this technology. At the end, it's yet another technology. It's the horse. Humans are the jockey. Let's collaborate with it. Let's endorse it and do better things.
Yeah.
Do better things together. And this era is about collaboration, conversational, and cognition, right? Which you have talked a lot about. Let's go to a jargon, right? Like everybody has one. This time VCs like us also have one. There is co-pilots, there's agents. We call it teammates. God knows they're called assistants, genies. So what's all this, right? Like what's your view on this agentic architectures, co-pilots? What's really happening? It's too confusing to the end user.
I think the simple way to envision, I think of this just taking inspiration from how the web came about, with hypertext and then the protocols around the web, whether it is HTTP or you had a browser, which was basically became the UI for the web. There were web servers that served up the pages, and there were these protocols as I was describing it. So if you sort of take that, we are building the agentic web.
Correct.
So if you're building the agentic web, the first thing is there's going to be a UI layer, right? Even for what is a fully agentic web, at some point they need to interface with us, whether it is to take a prompt, to take some instructions, to do some notifications, So the management layer of these agents is going to be with a UI layer that meets human and human workflow. So that's what CoPilot is designed for, right? So the concept of CoPilot is that's the UI for AI is how I describe it. So that's one side of it. The other side of it is, okay, what is the web server? So you can even think of that as the browser.
Browser, yeah.
Right? So then the next thing is, okay, what's the model equivalent of a server? The web server. And that's where we think of like what we are building with Foundry as the factory to build these agents. These agents will also come with multiple modalities. Agents that are really conversational agents, which are fundamentally about the human UI. There are semi-autonomous agents, which just take a high-level intent, go create a plan, go execute, and then come back. Maybe there's a fully autonomous agent, but even a fully autonomous agent at some point, I like to say, will do a PR to a human and
Absolutely.
say, please review, right? So that if you envision it that way, then the UI layer, the factory to build agents in multiple modalities, and then all of these are going to be required. So instead of having narrow arguments about, in fact, a lot of people I think say we're going to move from one phase to the other. No, we're going to have all of it, right? We'll need the CoPilot. The CoPilot will be able to invoke agents. Those agents will have multiple forms, and that I think is the way to go about it.
Got it. Let's talk about another favorite topic. I always like to be positive, but many industries, like what happened in the e-commerce arena, let's use the right word, have to reimagine themselves. So like enterprise software moved from perpetual license to subscription with SaaS, and now it's going to move to consumption or outcome-based pricing, which companies like you pioneered, both what you did with Office 365 and then with Azure, the consumption model. What do you think SaaS companies need to do? They own all the data. They have all these software interfaces. Using an agent or a co-pilot, I may not need to go to all these places. How do they reimagine themselves? Some of them will be around. Some of them.
I think, I think it's the right way to even think about it, right? After all, when was the last time enterprise software changed? SaaS was a big change. It was a change in how we built the software, how we licensed the software, or the business model around it. And same thing happened with servers, right? They moved to cloud. They became, how we built it, the business model became consumption versus licenses, and so on. So I think that's what's going to happen. Is that it's the moral equivalent. When I look, for example, when I go to CoPilot, and I use this new agent we just launched called Researcher, right? If I'm prepping for a meeting with a customer, I just go and say, hey, I'm meeting a customer. Here is the name. Can you prep for me by looking at everything from the web and work and all my business systems? So, for example, I don't go to my CRM system and pull it out.
Yeah, you're in your agent.
The researcher goes and pulls all of it together and synthesizes it. It has citations. I can always go look at it. Just like how we do it on web, you can now do it on the internal enterprise data graph. So that is the world, right? So this idea that I'm going to hoard data in silos, it's just not going to work because you're flowing against the current. So what are business applications? Business applications have a lot of IP in the schematization of some business process, right? So there's a lot they've done to essentially digitize what is a business process. That's all in a database. Then they write a lot of business logic around it, and then they put a UI. So I think it behooves all of us who are in business applications. That's what we're doing with Dynamics, right? So this sales agent talks to researcher agent, then I invoke from CoPilot. So it's a complete new way. Instead of going to a browser tab, the agent is going to come to you.
Absolutely.
Now, the user is not going to come to you. So you have to rethink the business model and say, more agents are going to use my app. I mean, the reality is, let's face it, if you look at the MAUs of any SaaS application, they're pretty low.
Yep.
In fact, it's always used to surprise me that the amount of money some of these SaaS companies make to the amount of usage they have is to me like, wow, that's an unbelievable gig. And then I say, wow, that's going to change. But it also could mean many more agents now can come at it, but it's going to be disruptive. So if you have
Absolutely.
a very high-priced user product, you'll have to rethink.
Absolutely, right? And I think what you're talking about, researcher, if I abstract it for people, it's really a digital companion, which is helping me amplify my skills and get my work done faster and better.
That's right.
And that's how this technology will manifest itself, right? Like, we have time for a few more questions, right? Like, you and I were trained in the Microsoft era. We are a platform company, platform company, platform company. And you say that again and again. And Microsoft built, and even today, has the biggest ecosystem. So where are there partnership opportunities for people in the room, people who are watching?
I'm glad you brought us back there, because when I look around this room, I see what is the relevance of a company like ours, which is, in the sense, our fundamental ability to continue to innovate depends on the innovation of our partners around our platform. I had a chance to even go around briefly in the trade show floor here, and it's just unbelievable. To your point, there are people building some new ASICs and systems. How can we use it? Quite frankly, can we be a customer in Azure? Can we use it? Can we then make it available to our joint customers? Go up like you're building a SaaS application for the new era. You're building an agent. How do we really give you the best core, platforms to do that, whether it's from GitHub Copilot to Foundry to our data services. So our goal would be to really, I always say Microsoft is both a platform company and a partner company.
Yep.
So platform first, partner first. And by the way, the amount of value, the platforms are only stable if the amount of value that's created about the platform is more than what's the value in the platform. And I think that that's what has gotten us so far in our journey, and that's the sort of the core ethos of what we will continue to carry forward.
Great, right? Rapid fire, which wasn't planned. Favorite app in the AI space?
For me, obviously, I would say GitHub Copilot is my favorite, right? I would always say Excel used to be my favorite app. It just, it's just one of those beautiful, artifact, the idea that a spreadsheet can change your relationship with numbers. Similarly, I think GitHub Copilot changes the relationship you have with your code bases. Like the repo, right, and a tool like GitHub Copilot, you can go in with confidence to any repo out there. And so that's probably my favorite app.
Great. One thing AI won't be able to do, right? People say
that 35 ball 100.
30, exactly.
That's it.
Exactly. I think it's parenting, right? And then, right, I think finally, a lot of entrepreneurs in the room, any product you want from them?
I would say, I think you pulled the thread on this, right? Which is, I think, the science and physical space. These are the two new frontiers. So I would love to be in that fast feedback loop on what's the next thing that you may be doing. I mean, somebody, what's going to be happening in robotics is just going to be transformative, right? The idea that you can now wire, like you can 3D print a robot arm and then have a connection back to a model, which is a real world model. Like those are the kinds of things that I would love to see. What is the next phase of compute intelligence be much more pervasive in the physical space and in science?
Great. Guys, back to the beginning. Let's thank Satya. Standing ovation.
Thank you all.
Thank you so very much. Navin, what a great job. Picture with the... Give it up for both of them again.
Thank you very much.